Hey everyone, in this video, we're going to look at example 2 in our section on 6.1. All right, so in this case, we're asked to find the area of the region bounded by the curves given in terms of y. So 1 minus y to the fourth is equal to x, and y cubed minus y is equal to x. So notice how the nature of these graphs or these curves are different than what we've been seeing before. So typically, when we're given a function y equals some function of x, our functions are functions of x, meaning they pass this vertical line test. For every one input of x, there's only one output of y. But we can also define functions in terms of y. So say g of y equals x. So for each y value we want, we get a value of x. Okay, so our world is just a little bit rotated. That's all we're doing here. So then when we're computing something like the area between two curves like this, it's the exact same process that we've seen when we have functions or curves defined with x, but now we just rotate our orientation. So we still look at what a slice would be looking like on this area. And we see that we'd have slices cutting across this way so that we cut between our two functions. So, and if we notice, we can try to identify which function is which. How might we do that? Well, we could just pick a point on our curve. So here, 0, 0 is on my curve. And I could ask, well, which of these functions is 0, 0? 0, 0 is on which? So we can just check. I'll plug in 0 for x and 0 for y. Is 0 equal to 1 minus 0? Nope. So that means this curve, 1 minus y to the fourth, does not contain 0, 0. We can just check to make sure the other curve does. So 0 equals 0 cubed minus 0. That just gives me 0 equals 0, check. So this point is on my second curve. So I can go ahead and label these two curves so I know which function is referring to which curve. So we saw here that that first curve would be x equals 1 minus y to the fourth. And my curve then on the left would be x equals y cubed minus y. Okay, awesome. So now we have several things figured out. Again, so now when we're computing the area, we're just integrating where we're taking slices that are perpendicular to the y-axis. So that means we're chopping up these slices along y. So that means the value, the variable that we're differentiating or integrating rather with respect to is y. So I have a dy. So now I need to consider the two functions that are bounding my area. So similar to the case when we were looking at functions defined in terms of x, now we just need to look at how would we measure the length of this slice. So we just use the same method. We're going to subtract the larger function by the smaller function. So we see here that the larger one, since we're orientating to the right, is our positive or larger, to the left is negative or smaller. We'd start with our function 1 minus y to the fourth. Then we'd subtract our function y cubed minus y. And so now we just need to check what are those integration bounds. Well, the largest value of y that we're going to start with is 1, and the smallest value we're going to go to is negative 1. So those bounds go from negative 1 to 1. So here's the integral that we need to compute. So at this point, please pause the video and make sure you're feeling comfortable with the integral that we have set up here so far. If I can circle it. Okay, so now we just need to compute this integral. So to do that, I'm just going to go ahead and subtract the second function just so that I don't get confused with my negatives and my parentheses. So this becomes the integral from negative 1 to 1. of 1 minus y to the 4th minus y cubed plus y. That second negative changes to positive when I bring in that negative sign, dy. So now I can just compute the antiderivative of each term. So it's just like what we've been doing, but we're just using y instead of x's, but all the rules still apply. So here the antiderivative of 1 is just y. Antiderivative of negative y to the 4th, well, I have my negative, but then I add 1 to the exponent, divide by the new exponent, so y to the 5th minus 5. Similarly, the antiderivative of negative y cubed is negative y to the 4th over 4. And the antiderivative of y is going to be y squared over 2. And you can check this by differentiating these antiderivatives that you just came up with. So now we're going to evaluate here at y equals negative 1 to 1. So what does that look like? When we plug in 1, we get 1 minus 1 to the 5th, which is just 1. So I can just write 1 over 5 minus 1 to the 4th over 4 plus 1 squared over 2. Now I'm going to subtract when I evaluate at negative 1. So we've got to be careful with our signs here. So I get negative 1 minus negative 1 to the 5th leaves me with a negative still. So negative 1 over 5 minus negative 1 to the 4th leaves me with a positive 1 over 4. And then negative 1 squared leaves me again with a positive 1 over 2. All right, so if we're careful to clean this up, be really careful with our negative signs, subtract these two values. In the end, we're going to get the total value of 8 over 5. So our answer here is going to be 8 over 5. And that is going to be the area between the two curves specified. Awesome job. All right, in the next video, we're going to look at a summary of these two different ways of computing area bounded by two curves. Thanks for watching.